Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories. How Dmitri Mendeleev organized chaos and changed how we see the world. In the far reaches of 19th-century Siberia, the kind of place maps treated like an afterthought, a boy was born in the town of Tobolsk who would one day reorganize humanity's understanding of matter. At that moment, though, there was nothing grand about the setting. Winter ruled the calendar, distance ruled opportunity, and survival had a way of simplifying life's priorities. As the saying goes, hard ground makes strong roots, and this ground was as hard as it gets. That boy was Dmitri Mendeleev. He arrived in a household that was busy, loud, and permanently negotiating resources. A big family doesn't just raise children, it runs like a small ecosystem. Meals required logistics. Silence was rare. Privacy was theoretical. Being the youngest meant Dmitri learned early that if he wanted attention, he'd better bring something interesting to the table. Luckily, curiosity was already his specialty. His father was an educator, disciplined, intellectual, a believer that knowledge was the one possession nobody could confiscate. His mother managed the practical realities of survival with quiet steel in her spine. The family wasn't wealthy, but it was rich in one crucial currency: respect for learning. In a frontier environment where many people measured success in livestock or land, this household measured it in books and ideas. And Dmitri? He gravitated toward anything that changed. Bottles fascinated him. Powders intrigued him. Liquids felt like puzzles waiting to confess their secrets. While other children treated household objects as toys, Dmitri treated them as evidence. He mixed, observed, compared. When water boiled, he didn't just see steam, he saw a question mark rising into the air. Why does it change? Why now? Why like this? Curiosity, as another old saying goes, opens doors no key can unlock. Dmitri was already walking through those doors. His father's bookshelf became his unofficial laboratory manual. He would flip through chemistry texts with the seriousness of someone decoding a private message from nature. He didn't just read, he reenacted. Experiments were mimicked with whatever materials he could find. Observations were narrated out loud, partly to make sense of them, partly because thinking sounded clearer when spoken. In his imagination, elements weren't dry abstractions. They were characters with personalities. Some were energetic troublemakers. Others behaved like calm diplomats. Dmitri mentally lined them up, compared their habits, invented little dramas about how they interacted. It was play, but it was structured play. Even then, he wasn't just fascinated by individual behavior, he was hunting for patterns. Teachers noticed. This wasn't just a clever child memorizing facts. Dmitri had a knack for organization, a mind that instinctively sorted complexity into structure. Where others saw scattered details, he saw relationships. He could take a messy explanation and tighten it into something clean and intuitive. Add a streak of humor, and suddenly difficult ideas didn't feel intimidating anymore. He had a natural storyteller's instinct. If a concept was complicated, he'd wrap it in metaphor. Molecules became dancers. Reactions became negotiations. Rules became rhythms. Classmates found themselves laughing and remembering. That combination would later define his teaching style: precision delivered with personality. At 17, Dmitri left his Siberian home and traveled west to pursue formal scientific education. The journey wasn't just geographic, it was psychological. He was stepping from the margins of the empire into its intellectual bloodstream. For a young man raised at the edge of civilization, the city felt electric, laboratories buzzing with new theories, debates spilling into hallways, ideas colliding like charged particles. He fit right in. In academic circles, humor became his social currency. Dense chemical principles were translated into vivid analogies. Atomic behavior became choreography. He'd compare orderly reactions to disciplined schoolchildren and chaotic mixtures to a class left unsupervised. Students laughed and learned. The atmosphere around him felt less like a lecture and more like an invitation to think. Behind the jokes, though, was relentless discipline. Dmitri recorded everything: measurements, variations, failures, especially failures. His notebooks were meticulous lines of numbers arranged with the care of someone building scaffolding for future insight. People joked that his records were more precise than the instruments themselves. They weren't far off. He believed deeply that nature wasn't random. Complexity wasn't chaos, it was hidden order waiting for the right lens. Measure twice, cut once, goes the carpenter's proverb. Dmitri lived by a scientific version of that rule: observe carefully, conclude cautiously. Early in his career, he threw himself into studying densities, gas behavior, phase changes, the physical fingerprints of matter. Long nights in the laboratory became routine. Glassware cluttered his workspace like a small city of fragile towers. Even when exhaustion crept in, humor stayed close at hand. He once held up a beaker and quipped that liquids behaved better than students in a queue, always finding their level. The room laughed, but the point stuck: nature obeys rules, even when we don't yet understand them. Failures never rattled him for long. If an experiment misbehaved, he'd shrug and joke that the elements were having an off day. Tomorrow, they'd cooperate. That lightness wasn't avoidance, it was resilience. Science demands patience, and Dmitri cultivated it like a craft. His laboratory became a lively arena of conversation. Discussions bounced between technical detail and playful analogy. To him, understanding science was like learning music: once you feel the rhythm, the structure reveals itself. Students didn't just memorize outcomes, they learned to anticipate patterns. Industry soon took notice. Dmitri wasn't content to let chemistry live exclusively in textbooks. He explored applications in fuel efficiency, resource management, metallurgy, practical problems where scientific thinking could save material, time, and money. He liked to say that science should earn its keep, not just decorate journals. As his reputation spread, invitations arrived from across Europe. Academic circles appreciated his clarity, but they were equally charmed by his personality. At international gatherings, he could pivot effortlessly from rigorous explanation to a playful metaphor that made a roomful of scholars grin. He treated scientific dialogue less like a duel and more like a shared puzzle. Even as recognition grew, his core philosophy remained steady: science isn't about memorizing results, it's about recognizing order. He urged students to look past formulas toward the logic underneath. Patterns were the real treasure. And all the while, quietly, persistently, his fascination with organization deepened. He had spent years cataloging behaviors, comparing properties, lining up data like puzzle pieces. Somewhere in that ocean of notes, a larger picture was beginning to take shape: a suspicion that elements themselves might follow a grand rhythm. For Dmitri, this wasn't mystical. It was inevitable. If nature loved patterns and his entire career suggested it did, then chemistry must have one too. The boy from Siberia who once imagined elements as dancing personalities was now standing at the threshold of proving that dance had choreography. And as any seasoned observer knows, fortune favors the prepared mind. His mind was more than prepared. It was ready to listen to what the elements had been saying all along. By the time the periodic table had taken shape, it wasn't just a scientific framework to Dmitri Mendeleev, it had become part of how he thought, joked, and even socialized. To him, elements weren't lifeless entries in a chart. They had personalities. Sodium and potassium were energetic dance partners. Chlorine, the picky observer standing off to the side, judging everyone's rhythm. And when he described chemistry like that, something remarkable happened: people remembered. He believed science didn't have to sound like a courtroom transcript. It could and should feel alive. A spoonful of sugar helps the medicine go down, as the saying goes, and Mendeleev instinctively understood that humor was sugar for the mind. His lectures weren't just lessons, they were performances of logic. Students didn't simply memorize properties, they felt relationships. Patterns became choreography. Reactions became stories. As the years passed, his relationship with science deepened from discovery to reflection. He immersed himself in historical texts, experimental archives, and his own mountains of notes. To Mendeleev, knowledge wasn't static, it was a conversation across generations. He would remind students that science wasn't about reciting formulas like poetry. It was about seeing the hidden order that connects them. In his classroom, patience wasn't optional, it was a tool. He'd compare scientific understanding to tuning an instrument, rush it, and everything sounds wrong. Take your time, and harmony appears. Humor softened the rigor, but never replaced it. He wanted students to enjoy the pursuit, because enjoyment breeds persistence and persistence breeds insight. Meanwhile, the wider scientific world was catching on. His work circulated across Europe, translated, debated, admired. When invited abroad to present his ideas, he carried the same conversational tone with him. Audiences expecting dry formalism instead found a storyteller with the precision of a mathematician. He'd shrug off praise with a grin, insisting he wasn't performing magic, just listening carefully to what nature was already saying. And that humility had teeth. He wasn't content to stop at organizing known elements. He leaned into the predictive power of his framework. If patterns were real and the data insisted they were, then missing pieces had to exist. Like a detective mapping out a crime scene, he left deliberate gaps where undiscovered elements belonged. Some colleagues were skeptical. Predictions in science can feel like gambling. But Mendeleev trusted the rhythm. Measure twice, cut once. He liked to imply if the structure is sound, the future will fit. And when new elements were eventually discovered with properties astonishingly close to his forecasts, skepticism gave way to respect. The table wasn't just descriptive, it was prophetic. Inside the laboratory, humor remained his pressure valve. Failed experiments weren't disasters, they were negotiations with stubborn materials. He joked that nature was having an off day and would cooperate tomorrow. The message beneath the laughter was clear: persistence is part of the method. Science isn't about explosive breakthroughs, it's about steady listening. He carried that philosophy into education reform. Textbooks were rewritten under his watch with clarity in mind. He wanted chemistry to feel less like memorizing a phone book and more like learning a language. Each element had a character, each reaction a conversation. Students weren't just absorbing data, they were learning to recognize patterns in the world around them. Industry soon realized his framework wasn't just academic elegance. Metallurgy, energy efficiency, materials science all benefited from the predictive logic of periodic relationships. Mendeleev delighted in reminding audiences that science earns its keep when it steps outside the laboratory. Coal savings, improved alloys, smarter resource use, these weren't side notes. They were proof that understanding nature translates into practical power. His laboratory became an informal crossroads of international scholarship. Visitors found an environment equal parts discipline and warmth. Demonstrations felt like guided tours through nature's architecture. He'd point to orderly reactions and joke that the elements behaved better than most students, laughter again acting as a bridge between complexity and comprehension. As middle age turned toward later years, his pace didn't slow, it refined. He revisited decades of data, polished theories, mentored younger scientists. Reflection didn't dull his curiosity, it sharpened it. He often spoke of science as music: we don't invent the melody, we learn to conduct it. The periodic table, in his eyes, was a score and humanity was still learning how to play. Recognition grew, but vanity never took root. He continued urging students to question assumptions, to treat data as conversation partners rather than commandments. The proof of the pudding is in the eating. He'd imply theories earn their value through testing. His humor wasn't decoration, it was a teaching instrument that made rigor approachable. Beyond academia, his sense of responsibility widened. Science, he argued, shouldn't live in ivory towers. It should solve real problems: storage efficiency, industrial planning, agricultural stability. If chemistry could reduce waste or improve infrastructure, then it was fulfilling its social contract. Knowledge, in his philosophy, was meant to circulate like clean air. Internationally, his reputation evolved into something more than admiration, it became influence. Scholars remembered not just the table, but the man who presented it with warmth and clarity. He showed that authority and approachability could coexist, that serious ideas didn't require a solemn voice. Even in later life, his curiosity stayed restless. He'd wander into the lab, exchange jokes with students, then pivot seamlessly into deep discussion about scientific philosophy. To him, chemistry was still a dance, structured, rhythmic, endlessly revealing. And he never lost the sense that discovery was a privilege, not a possession. In the end, what defined Mendeleev wasn't just the chart that hangs in classrooms worldwide. It was the mindset behind it, patience paired with playfulness, logic softened by humor, discipline guided by wonder. Where there's a will, there's a way, says the proverb, and he proved that when will is combined with curiosity, entire systems of understanding can fall into place. His legacy isn't only a table of elements. It's a reminder that science is most powerful when it's human, when it invites us to laugh, to question, and to see order where others see noise. And in that sense, the dance he began is still playing every time someone looks at matter and asks, what pattern is hiding here? Late in life, Dmitri Mendeleev developed a habit that his students found both touching and a little theatrical. He would pause in front of his periodic table not as a lecturer, not as a celebrity scientist, but as if he were greeting old friends. To him, those symbols weren't ink on paper. They were decades of arguments with nature, sleepless nights, failed notes, stubborn revisions, and the quiet thrill of patterns finally snapping into place. He once joked to an assistant, "These fellows and I have been negotiating for half my life. I'm glad they finally agreed to stand in a straight line." It was classic Mendeleev, humor softening the weight of achievement. But underneath the joke was a profound sense of closure. He wasn't just seeing order in chemistry, he was seeing proof that persistence pays rent eventually. As the old saying goes, slow and steady wins the race, and he had walked that road one careful observation at a time. In those reflective years, he spoke less about discovery and more about responsibility. To him, science wasn't a private trophy case. It was a public tool. He pushed for industrial improvements, more rational use of resources, and education that reached beyond elite halls. He liked to say, half smiling, a chemist who only writes papers is like a baker who never feeds anyone. Students laughed, but they understood the message. Knowledge that doesn't touch real life is unfinished work. His classroom never lost its warmth. Even in later years, he animated elements like characters in a play. Sodium and potassium became energetic dance partners. Chlorine was the picky critic in the front row. Students didn't just memorize properties, they felt relationships. Mendeleev believed that if science stayed cold, curiosity would freeze with it. Or as another proverb puts it, you catch more flies with honey than vinegar. His honey was humor, and it made complex ideas stick. What made his teaching remarkable wasn't just wit, it was rhythm. He built explanations like stories, rising tension, moments of surprise, satisfying resolution. A lecture might begin with a simple question about atomic behavior and end with a sweeping reflection on natural order. Students walked out not just informed, but energized. He treated chemistry as a language, and every element had a voice. As his reputation spread, visitors from across Europe came expecting a stern authority figure. Instead, they met a man who disarmed rooms with a grin and a metaphor. During one lab tour, he gestured to rows of materials and quipped, "See? Even elements behave better than students when you arrange them properly." Laughter broke the ice, but what lingered was the elegance of the system behind the joke. He wasn't showing off a chart, he was revealing a worldview. Nature prefers patterns, and patience is how you learn to hear them. His later reflections often circled back to the nature of scientific work itself. He warned students against chasing shortcuts. Nature doesn't hurry, he would say, tapping the table for emphasis. Why should you? To him, observation was a form of listening, and listening required humility. He taught that a scientist's greatest tool wasn't brilliance, it was attention. Measure twice, cut once could have been his unofficial motto. Even as his pace slowed, his curiosity didn't. He revisited old notebooks, cross-checking data, marveling at how much insight had grown from simple questions. He described science as an orchestra, each element entering at its moment, each pattern contributing to a larger harmony. "We don't control the music," he told a group of students. "We learn the tempo." It was a poetic way of saying what he'd always believed: science is collaboration with nature, not conquest. Those around him noticed how seamlessly his personal philosophy and scientific thinking intertwined. He cared deeply about students not as apprentices, but as fellow explorers. He never played the distant genius. Instead, he positioned himself as a guide pointing at the map, reminding them that the territory was always bigger than any individual. A scientist, he liked to say, isn't a wizard alone in a tower. He's a detective in a world full of clues. His humor matured with him. It became less playful teasing and more gentle wisdom. When discussions turned heavy or debates grew tense, he'd lean back and say, "Elements may be mischievous, but their laws are honest." The room would settle. That line captured his lifelong trust in natural order. Confusion is temporary, but truth is patient. In conversations about society, he grew more outspoken about the role of science in everyday life. Efficiency, agriculture, industry, these weren't side interests. They were proof that chemistry could feed, build, and sustain. He insisted that scientific progress should translate into human benefit. Discovery, he told colleagues, is only half the journey. Application is where it earns its keep. It was his way of reminding everyone that theory without practice is a bridge to nowhere. Visitors expecting grand self-celebration instead found humility. When praised for his predictive genius, he waved it off. No magic, he'd shrug. Just careful looking. That modesty wasn't false humility, it was a philosophical stance. He genuinely believed the laws were already there, he'd merely organized the conversation. The proof is in the pudding, he'd say, pointing to successful predictions as evidence that careful reasoning beats flashy claims every time. In quieter moments, he would return to the periodic table with a reflective calm. He didn't see it as finished marble. He saw it as a living document, evidence that understanding evolves. To him, the table symbolized something larger than chemistry, the human capacity to find structure in chaos. He once mused, "We arrange the elements, and in doing so, we arrange our thinking." That insight reveals the heart of his legacy. Science is as much about shaping the mind as it is about cataloging the world. His influence radiated outward, students teaching students, industries refining processes, researchers extending patterns into new territories. Yet he never framed his work as an end point. He treated it as a foundation. The next step, he'd say, belongs to someone curious enough to ask better questions. He trusted that curiosity would keep the rhythm going long after his voice left the lecture hall. In his final years, what stood out most wasn't triumph, it was continuity. Humor still punctuated his conversations. Order still fascinated him. He carried the same belief that had guided him from the beginning: science is not a cold monument, but a living practice. Observation, patience, imagination, responsibility, these were the pillars he returned to again and again. And if you step back, that's the real portrait that emerges. A man who turned a chart into a language. A teacher who made complexity feel like conversation. A thinker who understood that laughter and logic can share the same bench. His life reads like the periodic table itself, structured, interconnected, full of surprises, and endlessly generative. Because in the end, his message wasn't just about chemistry. It was about how to engage with the world, look closely, stay patient, welcome humor, and trust that patterns exist waiting to be seen. Science, in his hands, became less about formulas and more about perspective. And that perspective still speaks. Curiosity is a muscle, order is discoverable, and a good joke can make even the heaviest ideas lighter. Like he implied so many times, line things up carefully, listen to what nature is saying, and the dance will reveal itself. The people who change the world usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.